Hello, hello, hello. How we doing? Who we got here? Hello, JJ. Hello, Rachel. Hi, Shannon, Kaula, Selena. Greetings. Hello, Daddy Pig. Hi, Angie. Lost maths paper. Hello, Valley. Hi, Mavis. Good to see you. What? It's our last lesson, huh? Our last one. The journey comes to a comes to an end. Greetings, Hussein. Hello, Zakira. Greetings, all of those that have been with me all the way from September. Greetings to all of those joining us for the very first time. Welcome, welcome, welcome. Yeah. How we feeling? Yeah, getting excited to be done with maths. Hello, Hal. Hello, Callum. Hello, Teresa. Hi, Kumrasamy. Good to see you. Yeah, just a little reminder, if you think any of your mates, see a ladybug. Yes, Mavis, that's true. It's for everything, Freya. Maths is maths. If you've got any mates who you think could benefit, then just send them the link. Get them in on the action. Hello, Banipreet. Nah, AXA, all exam boards. Maths is maths. It's the same national curriculum for every exam board. Maybe some of the questions are a little bit different. Maybe the order of the exams is slightly different. Not a problem. Yeah, so whatever exam board you're doing, I guarantee that there is something for you here. Yeah, thank you, Rachel. Yeah, so share the link with your mates. Get them in on the action. Get them involved. And remember, if you want to be commenting, anyone there? Oh, see you, Nick. That is correct, Shannon. If you want to be getting in on the chat action, asking lots of questions, make sure you're in subscriber mode. This is Foundation AXA, yeah. Then, oh, greetings, Yashi. Hope all was good. Hit the like button. Make sure you've got notifications on. Amazing stuff, JJ. Very, very good. Thanks, Sufyan. Final push. Yeah, yeah, yeah. So get notifications on. Give me some likes. Subscriber mode. It's everything Bolus D Hill. Hi, Maina. Hi, Tamina. All good. Hope you're all feeling good for tomorrow morning. Tomorrow's final exam. I love cats. I do too. Greetings, Ria. Hello, Elodie. And remember, might still be a few cram courses left. Check for the other subjects. This is foundation level maths. So there should be a higher level maths course going on at the same time as well. Calculators out. Yes, any questions you've got for the end, of course, we can stay a little bit longer and have a look at that. Tamina noted, please remind me again at the end, exterior angles. All right, well, it's gone half past. So I reckon we can start, huh? If you're ready to begin, say ready. Get in there, Cowler, huh? The end is in sight. Greetings, Donald. Hello, Safi Zakira. Hello, 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 hello. All right, nice. Blue W ready. Make sure you've got your workbook printed off. Links in the video description. Let's do it. All right. First three terms of an arithmetic sequence are 3, minus 1, minus 5. Write down the formula for the nth term of this sequence. Oh, well, this is going to have to take the place, Cowler, isn't it? So how do we find the nth term? Hi, Cleopatra. All right, we can see that to go from one term to the next, very good, Tamina. To go from one term to the next, we are subtracting 4 each time. Therefore, our sequence must be based on minus 4n. And what else? Find, what do you mean the first number, Kumarasamy? Very good. We want to think what the number before would have been. Yeah, so this is like the 0th number, the 0th term, I call it. So you add that onto the end. So minus 4n plus 7. Job done. So nth term is this. Cool. Now, how do we work out the 7th term? How do we work out the 7th term? I mean, there's two ways. Obviously, we could just sit and extend the sequence. Here's the first term, here's the second term, third term, fourth, fifth, but it's easier to substitute. So substitute n equals 7. So it's going to be minus 4 times 7 plus 7, which is, right, minus 4 times 7 is minus 28, and add a 7, we're going to get, what do we get? Minus 21. I agree with minus 21. Cool. And then number 3, explain why minus 1,000 is not a term of this sequence. All right, can anyone see? What do you mean it's not a whole number? Minus 1,000 is definitely a whole number, Yashi. Ah, when you rearrange. Okay, so there's two ways of doing it. Way number 1, this is the more general one. You just check, can minus 1,000 be the nth term? That's even better, Safi. Very good. So you go minus 1,000. Love cats, I can see your comments, absolutely. Minus 1,000. If it was the nth term, it would be equal to minus 4n plus 7. If you rearrange, you will subtract 7 from both sides. Minus 1,007 minus 4n, divide by 4. Divide by minus 4 rather, we're going to get minus 1,007 divided by minus 4 is equal to n, and we get n is not a whole number. Gamer gang, it will be for every exam board. However, there's a much easier way that some of you spotted already. Oh, I don't know, decided to leave, Ibs. An easier way, notice all terms are odd. Right, we can see that 3, minus 1, minus 5, and we keep on subtracting 4, we're always going to get odd numbers. Minus 1,000 is even, so it can't be a term. That's an easier way of doing it without having to do any algebra. Yeah, Charlie's, I've looked, yeah, it will help you for every exam board. I love cats. This is based on English exams, but it's still maths. All right, ready for the next one? If you're ready, say ready. Yes, thank you, Kaula, pointing out. If anyone's here for higher level maths, there's another stream going on at the same time. All right. Question 2. A large wall is to be painted in the design shown below. Calculate the ratio area of painted section to area of unpainted section in the form 1 to n, where n is written to 2 decimal places. What are we going to do here? Any ideas? Okay, let's find the total area first. That will definitely be a good starting point. There's a quarter circle there, correct, Yashi? Total area is 8.5 times 6.4, which is, get out your calculator, of course. So 8.5 times 6.4, 54.4. What units will the area have, by the way? Oh, don't worry, Safi. We haven't done everything yet. We're just finding the area of the whole wall first. We are going to need to do some subtraction. 54.4 what? Meters squared, right? Notice all of the lengths are in meters, which means we're going to be in meters squared. Nice. So now we want to identify shapes, right? We want to break it down into lots of different shapes. So what shapes can we see? Someone already said we've got a quarter circle. Let's call that area number 1. What else have we got? There is a triangle. Very good. It's a right angle triangle. Very good. All right, so let's make sure that we know what and a rectangle, right? Now, for the triangle, let's call triangle number 2, and then the rectangle can be number 3. And break them down bit by bit. Let's start with the rectangle, actually, because rectangles are easy shapes. What's the length and width of this rectangle? No Pythag needed here. Let's make sure we know. Okay, this is going to be 8.5. I agree. This is definitely 8.5. And what's the height? It's not 6.4. 6.4 is the whole thing. It's 6.4 minus 3.5, which is 2.9. Correct, Angie? Correct, Yashi. So area 3 is 8.5 times 2.9. All right. What about area 2? The triangle. Guess we should work out what that is, huh? So that 8.5 times 2.9. Two, 4, 6, 5. Area number 2, triangle. Greetings, Philip. Yeah, it is 1/2 times. Very good. We've got 6.8 here. Let me do it in red so we know that we're talking about the triangle here. That's 6.8. The height is 3.5. 1/2 times base times height. Star monkey, it's given here. So you need to look at everything and work carefully. All right, bye Yashi. Isha, this is geometry. So what's the area of this triangle? Thank you, Hussein, 11.9. And what about finally area 1? L, the 2.9 was the 6.4, which is the total, minus the 3.5, which is the painted bit. We'll see, Maynard. If I've got time at the end, maybe we can find one. How do you do area 1? All right, very good. The radius is 3.5. So we're going to use pi r squared. It is a sector, JJ, so what fraction of a circle is it? Here we see it's a quarter circle. So it's going to be a quarter times pi r squared. So it's a quarter times pi times 3.5 squared, right? Lots of people writing it without the r squared. Not just the triangle, Kaola, because look, we've got this curve as well, right? The unpainted is the whole thing, right? Before I drew all of the lines on, the painted bit is this, and unpainted is all the rest. For some reason, this person wanted a picture of some odd wave on their living room wall. How do you know it's a quarter, Tamina? Because if you imagine a pizza and it was cut into that shape, that means it had 4 pieces, right? Think about, oh, there must have been, that's now a semicircle, that's half. And then, oh, there's another quarter, and oh, there's another quarter. So this is a quarter of a circle. Kian, it's given here. This 3.5 is the same as the height of that sector, and therefore, hello again, Daddy Pig. So it is the radius of that circle. So quarter times pi times 3.5 squared. Make sure you know where the pi button is on your calculators. So 1/4, which is, I mean, you can do it as a fraction, or you can do it as a decimal. You should know that a quarter is 0.25. Quarter times shift, there's your pi button, and then times 3.5 squared gives me 9.62. All of them, Amal. This will help you whatever exam board you're on, meters squared. So now, how are we going to do the area of painted section to the area of the unpainted section? What do we do now? Yeah, all exam boards examine the same techniques. I'd say it's, yeah, maybe slight bias towards that Excel, but it will help you whatever exam board you're on. First add, then subtract. Okay, add them all up. So if we add them all up, that gives me the unpainted. So unpainted section is 24.65 plus 11.9 plus 9.62, which is, I mean, let's see, 24.65 plus 11.9 plus 9.62, 46.17. And then painted is going to be just the rest, right? The whole wall is 54.4. So your painted is going to be your whole wall minus your unpainted. Which is, what's that, 54.4 minus 46.17, 8.23. Kind of running out of space here. I'm just going to make myself a little answer box here. So our final ratio is 8.23. Kofi could be. I haven't seen it. To 46.17. But they want it in the form 1 to n. So how do I get it in the form 1 to n? It's foundation, Ijaz. How do I get it down? Right, we see we need to go down from 8.23 to 1. To do that, we are dividing by 8.23. So divide both sides by 8.23. So we go, we're trying to find 46.17. Divided by 8.23, which is 5.61. We want 2 decimal places, so it's 5.61. All right, job done. Ready for the next one? Say ready. All right. Cool. Sketch the line y equals 5 minus x. Label this line A. How do we do that? How do we find the line y equals 5 minus x? Oh, Cowler, the red bit. A rectangle instead of a triangle. Oh, because look, it's a diagonal line, so it has to be a triangle. So, how do we do this? A table of values would be one way if you're really, really not sure. Yeah, let's do a table of values. Why not? And you don't need much. How many values do you need to draw a straight line? Maybe I will, Ibs. How many values do you need to draw a straight line? You actually only need 2. To find a straight line, you only need 2 points, and then you join them up and you get a straight line. Because you know it's a straight line. Okay? So actually, I would say, okay, when x is 0, y is 5 minus 0, which is 5. So that's the point. X is 0, y is 5. There it is. When x is, I don't know, 4, y is 5 minus x, so it's 5 minus 4, which is 1. So that means we've got x is 4, y is 1. Here it is, and here is the line. Done. Label it A. Okay, you only need 2 points for a straight line. Also, notice we could have just done it, and some of you were saying it. We know what's the general equation of a straight line? Well, MN, does that not mean that you're going to be ready for anything? Y equals mx plus c. So, c means your what? It's your y-intercept. And we can see that this line has a y-intercept of 5. Here it is. Right, we could have written it as y equals minus x plus 5. So here's our intercept of y. And then this m is the gradient. So the gradient here is minus 1, which means for every step you go along, you go down by 1. Down by 1. Number 2. Sketch the line y equals 3. Label this line B. Where is the line y equals 3? Across? Right, yeah. Every point on the line y equals 3 has a y coordinate. It's horizontal. Has a y coordinate of 3, which means it looks like this. There it is. Star Monkey you could, but you'll find that x equals 0 will be, sorry, y equals 0 will be off the graph. But yeah, of course, you can start from there. And if it doesn't work, then you do something else. So all points have a y coordinate of 3, which means all points have to line up with a y value of 3. We could have picked any other number, Tamina. I picked x values that I see on the axis. And number 3, what about the line x equals minus 1? Right, if y equals something is horizontal, then x equals something is vertical. All points have an x coordinate of minus 1, so all points have to line up with this minus 1. You end up with a vertical line like this, and label it C. All right. Light stuff. Ready for the next one? Say ready. Right. Good. Lovely. Okay. A number C is rounded to two significant figures. The result is 50 million. Write down the error interval for this number. Okay, error intervals. How do we do them? Otherwise known as upper and lower bounds. How do we do it? Here's the way I do it. That's exactly correct, Rochelle. It's the smallest and the largest that would round to 50 million, but we are talking about two significant figures. So first we need to figure out where the cutoff would be. Okay, we're saying what numbers would round to 50 million to 2SF. Now, first of all, two significant figures. What does that mean? Two significant figures means we're counting the first two digits from, the first two numbers, starting from the first one that isn't a zero. So it's the 5 and the 0. That's our two significant figures, and there is our rounding cutoff. We're rounding here. So in other words, if the digit after the rounding thing is like a 1, 2, 3, or 4, it will round down to 50. If it's a 9, 8, 7, 6, or a 5, it will round up to 50. So that means the absolute biggest it can be is going to be, you just basically change the number straight after the cutoff to a 5. So you go 50, 500,000. And then, to get the lower bound, you reduce the number before the cutoff by 1. So it becomes a 49, 500. That's the quickest way I've got, Amal, of doing it. You write out the number. Correct, Tamina, but notice that we've got less than. So less than means we could actually be on 50,000, 50,400,999,999, like this, and that would indeed round down. So this is basically the first number that doesn't round down. So, yes, Brenda, of course. Think of it this way. Imagine you've got, I don't know, 50,437,000. Would this round up to 51 million or down to 50 million? This would round down. Yeah, but Fatima, look, if you've got 55 million to two significant figures, that's just 55 million. Okay, so that one is in the error interval because it rounds to the number we've got. What about, let's go a bit higher. What about this one? Would that round down? Is that in our error interval? It still rounds down. So that's still in our error interval. What about this? What would that round to two significant figures? That rounds up to what? 1, 2 significant figures. The 5 rounds it up to a different number. So that means that something funky is happening in here. Something in between those two numbers changes things. Something's happening here. So the cutoff where we change from going down and going up, Millie, people find this hard. The cutoff from going down to going up is exactly this. So here is my trick of doing it. It's 2 marks here, right? A mark for getting the right upper bound, a mark for getting the right lower bound. So the way I do it, I write out the number. I then put a line where we're rounding. I change the digit after the line to a 5, and that is my upper bound. And then I decrease the number before the line by 1, and that is my lower bound. Done. All right. Ready for the next one? Yeah, guys, be nice to each other, please. Just because you find something easy doesn't mean everyone does, and just because you find something hard doesn't mean everyone does. I'm trying to cater to everyone here. It's all love. We've all got an exam in the morning. It's not a problem. Let's go. Ruxana is organizing a fundraiser party. She spends £80 on drinks and snacks. Oh, that was just a random number, Kian, that I picked out of nowhere. She spends £80 on drinks and snacks, £155 on venue hire, £120 for a DJ. Ruxana wants to make a percentage profit of at least 15%, and she expects to sell 75 tickets. How much should each ticket cost to meet Ruxana's profit target? Right, paper 3 tends to have a lot of these wordy questions. So what can we make of it? What do we do here? Add up her costs. Good. So total costs. What's that? 275 plus 80, that's 355. Okay, so that's the costs. Now what? Guys, keep it locked in, please. All right, we've moved on from the last question. We're on this question now. Question 4 is a yesterday problem. Not yet. Correct, Callum. Correct. You should totally explain. You should signpost your working. I'm not saying write an essay, but explain what each step is. Very good. So we need to make... Right, we need to make 355 increased by 15%. So essentially we're saying if our percentage profit is 15%, then we need to make 15% more than what we spent. So 15% of 355. Also, Brenda, yeah, there's loads of ways of doing it. You can do it with a multiplier. Yes, 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 absolutely. In other words, we're finding 115% of 355, or we're finding 15% of 355 and adding it on. 15% of 355 is indeed 53.25, and therefore need to make 355 plus 5325, which is 40825. Now what? Divide by 75. Right, that's how much we need to make, and we need to make that from 75 tickets. Maynard, depends on whether the working's correct or not, but I really recommend trying to tell a little bit of a story, right? So what I'm doing here is I'm kind of trying to explain everything that I'm thinking. What am I doing? I'm finding the total cost. I'm trying to find what I need to make. I'm trying to find the cost of each ticket. I'm signposting my working so that I'm showing the examiner, oh, I do know that I need to divide it by 75 or whatever. So let's see, 408 pound 25 divided by 75 is £5.44. So do I round this down or up? This is not reverse percentage to me now, but I think I've put one in if I remember correctly. And if not, we can do it at the end. I would round it up. Why would I round it up? Here's why. If it was 544 and you sell 75 tickets, if you've rounded down, you're going to end up with slightly less than what you need to make. Exactly, she needs to make at least 15%. If you round it down, then you're always going to be getting a little bit less because you always round it down. So we should round up because she wants to make enough money. Tickets should cost at least £5.45. Tamina, we divided because that total amount of money needs to come from 75 tickets. So this needs to be made from 75 tickets. So each ticket should make 1/75 of that. All right, ready for the next one? Any questions? By all means, interrupt with questions anytime you like. Okay, cool. All right. Town B is 10 kilometers from town A on a bearing of 70 degrees. Town C is 6 kilometers from town B on a bearing of 200 kilometers. By drawing a scale diagram, find the distance and bearing of town C from town A. Scale diagram. Ready to rumble. What we thinking is a suitable scale here? What's a reasonable scale? With scale diagrams, first thing we need to do is pick a scale. Gunny, we can do it at the end, don't worry. Now pick a scale first. Don't start from north just yet. We need a scale. We need to know how big our drawing's going to be because this is a scale diagram. I would pick something like 1 centimeter. No, I know 1 kilometer is 1,000 meters, but on my page, I don't have a kilometer of space. So 1 kilometer, about centimeter. That's what I would pick. That seems reasonable because I can see my distances are going to be like 10 centimeters and 6 centimeters. That makes sense to me. I wouldn't pick 1 centimeter as 10 kilometers because everything's going to be too small. Absolutely, Bolisti, you would have to pick a scale that's going to make sense with the size of your page. Generally think, I mean, you've messed around with a ruler before. You know how big 10 centimeters is. You think, can I draw 10 centimeters on this page? Usually, yeah. Right? You should end up drawing things that are about 10 centimeters. So let's do it. Here's our sketch. Town B is 10 kilometers from town A on a bearing of 70 degrees. So let's start with town A. How do I find a bearing of 70 degrees? All right, I'm going to do it roughly first, and then I'm going to do it properly. It's kind of hard here digitally, but we'll try. We are going to need a protractor, but how do we know which way to go? Which way 70 degrees is? Yeah, but 70 degrees from where? From north, good. Clockwise or anti-clockwise? So here's the north direction, and we want to go clockwise from north. So you want to measure 70 degrees clockwise from north, and then you want to draw 10 centimeters measured with a ruler. So this is 70 degrees with protractor. 10 centimeters with a ruler, and that gives us town B, because town B is 10 centimeters on our drawing from town A on a bearing of 70 degrees. Tick, done. Now, what about town C? Once again, do another north line. We want to go 200 degrees. Now, 200 degrees, I know 180 degrees is this much, so it's going to be another 20 degrees. There's 200 degrees. And then we do a 6 centimeter line. And that is point C. And now we want the bearing of town C from town A. What do we think? Absolutely, Ibs. You absolutely have to, because that's how you measure angles. So remember, a bearing is always measured from north. It's always measured clockwise from north. Well, it depends on what the question tells you, Amal. So I need to look. Here they've told us B is from A, so you do the road from A to B. And then it's told us C from B, so we do the road from B to C. Yes, it does, Polly, because here we're using a scale diagram, so it has to be accurate. We have to use rulers and things. Now what you do is you measure this length. And we want so that's the distance. And we want the bearing of C from A. We also need to measure this angle. So you measure the angle with a protractor. You measure the distance with a ruler. Yeah, you're going to get it in centimeters, and then you use your scale to convert back to kilometers. So let's see now. Do I have a protractor? Let me see. No, maybe I don't have a protractor. No, maybe you're just going to have to believe me. Let's see what you're getting, though. Let's see if we're all agreeing with each other. Okay, let's see. 7.5 centimeters, 8 centimeters, close enough. What else are people getting? Let's get some answers. No, you don't use Pythagoras. You literally measure with a protractor and a ruler. Right, all of those telling me you don't have protractors, don't you dare go to your exam tomorrow without a protractor. Right, Tamina, at the end, all right? Oh, okay, hang on. I'll get a protractor. We'll do it properly. Just give me 1 minute. Give me 1 minute. It's coming, guys. Be patient, be patient, be patient. Okay, almost there, almost there. Let's see. Protractor. Okay, cool. So here's how you would do it. Oh, can I not change the size? Oh, that's a pain. Oh no, I'm going to destroy everything. Okay, so we start with our nice little north line. Okay, there's a north line, and now I'm going to add my 10 centimeter. In fact, you're asking how to use a protractor, huh? So I'm going to set my protractor so that its middle is right on the base of the north line. And then I want 70 degrees, so I insert my line so that it goes through 70. And then using my ruler, I make sure that it is 10 centimeters long. Now, I want to get 200 degrees at this next point. So once again, maybe I should, don't know why the default color is yellow. It's not a very good default color. There we go. So now I move my north line to up here. That was my 10 centimeter line. I want 200 degrees, but 200 degrees doesn't exist on my protractor because it only goes up to 180. So what do? I know it's going to be 20 degrees beyond that. So I'm going to turn it around. And get 20 degrees beyond 180. Oh, no, thank you. Sorry. Sorry about that. Oh. All right, start again. So we start off with, it's not pre-recorded. All right, here's your north line. You get your protractor. You line it up with the base of your north line. You then get your ruler. You measure out a 10 centimeter line that lines up with 70 degrees like that. And then that's your first line. You then draw another north line over here. You try to measure 200, but you see, oh, hang on, this only goes up to 180. So you go 20 more than 180. So you're going to turn this around and go, aha. So from that point, we need an extra 20 degrees. So you insert another line starting from that point, and it goes through 20 degrees, and it's a length of 6 centimeters. And then you measure the distance from your start point to your end point and the angle that it makes from north, which is going to be something like this. All right. Now that's because, Rashida, that's because I was looking at the protractor instead of looking at the chat. That's why. I mean, if you think this is pre-recorded, that's up to you. But anyway. Right, sorry about that. The north line is not a number. Ready for the next one? Hi, Niharika. Rashida, because I was looking at the PowerPoint instead of looking at the chat. You know, I was trying to get it work, and that's why I didn't realize that it was black. If it's pre-recorded, how am I answering your comment right now? All right. Simultaneous equations. Let's do it. How do we do it? We've got 4x plus 5y equals 6, 3x plus 2y equals 1. All right, we need to make the numbers in front of either x or y equal. I prefer to do y. So let's make the numbers in front of y equal. Ah, that would be y. So A, B. So to make y's be the same thing, or make x the same, I'm going to make y the same, okay? So what number can I make in front of y? Yeah, times the first one by 2, so 2a is going to be 8x plus 10y equals 12. Multiply everything by 2. And the second one I multiply by 5. Good. So multiply by 5, I'm going to get 15x. Multiply by 5, I'm going to get plus 10y. Multiply by 5, I'm going to get 7. Now what do I do? I've got two equations where the number in front of y is the same. Oh, then it was pre-recorded. Pre-recorded 10 minutes ago, huh? What do I do now? Subtract them. Very good. If they've got the same sign, we have to subtract. And the way I do it, I just draw a line and I go 8 minus 15 is going to be minus 7. Oh, sorry, 5. My bad. Thank you, Tamina. Well spotted. 8 minus 15 is minus 7x. 10y minus 10y cancels out, and then 12 minus 5 is 7. That's why I wrote 7. I was thinking ahead already. Yeah, too much of a hurry. Now what? How do I find what x is now? Divide by minus 7. So x is going to be 7 divided by minus 7, which is minus 1. So how do we find y now? Nah, Rashida, they know what they're doing. They read the chat. Now we substitute. Which equation should we put it into? Chizoba, because you want to make them up. You want to make one of either x or y have the same number in front. So you look, you've got a 5 and a 2. Okay, let's make them both be 10. That's how I did it. All right, use equation A. So equation A is going to become 4 times minus 1 plus 5y equals 6. So minus 4 plus 5y equals 6. So what do I do now? Correct, blue W. Nice. Add 4 to both sides. Sweep. 5y is going to be 6 plus 4, which is 10. And so y is, divide by 5, y is 2. Nice. Now, once you finished a simultaneous equation question, I always like to just put the results together so that no one's looking for them all over the page. So at the end, you just go, so x is minus 1, y is 2. Just make it easier, right? Remember, the person who's going to be marking your exam is going to have a pile of 200 of them. They're going to be spending their summer holidays marking a pile of 200 GCSEs. So make their life easy, because people that are marking a pile of 200 GCSE papers on their summer holiday are probably a little bit miserable. If you make their life easy, it's easier for them to give you marks. So signpost your work in, right? Make your story easy to follow. Correct, Shannon. Oh, extra money, that's why. Ready for the next one? Oh, I don't know, Maynard. If you're ready, say ready. Yeah, you're right, Blue W. You will get spaces at the bottom, but it's still a nice idea to just highlight what you've done. A coach is driving at an average speed of 52 kilometers per hour on a journey of 120 kilometers. Work out how long the journey lasted in hours and minutes, rounded to the nearest minute. Okay, so how are we going to do this? All right, what's the formula here? Speed equals distance divided by time. Which means what? Now we want how long, so what are we looking for? Time is correct. Distance over speed. So, okay, so time is distance over speed. Very good, which is going to be 120 divided by 52, which is what? Okay, so that is 2.30769, bunch of stuff. Now, how do I convert that to hours and minutes to the nearest minute? Does that mean 2 hours 30 minutes? Thing on your calculator. All right, let's see. So we had 120 divided by 52. That is some horrible number of hours. Yet multiply it by 60 to get it in minutes. So to the nearest minute, it is 138 minutes. So to go from hours to minutes, you multiply by 60. So it's 138 minutes to the nearest minute. Oh, even better, Hal, but it does want the nearest minute, so we don't need seconds. This is 2 hours and 18 minutes. Do not make the mistake, absolutely do not. Remember, 2.30 hours is not 2 hours 30 minutes, right? That's like rule number 1, decimal time in hours. Cowler, you can do it that way, but it's safest, since you've got this on your calculator, just multiply it by 60, and then you see, aha, so that is the same as 120 plus 18, and 120 is your 2 hours, 18 is 18 minutes. The best way to do it is to convert the hours into minutes by multiplying by 60 and then just pick out the hours from that. Or yes, you might have time conversion on your calculator. Depends on the calculator you've got. This one's got it. So if I go, let's try that again. So 120 divided by 52 equals this. 2 hours, 18 minutes, 27 seconds. Right, there we go. Greetings, Alara. Yeah, so you can do it using that button on your calculator, that's here. But the other way is you just multiply by 60. You know that there's 60 minutes in an hour, so if you've got the number of hours, you multiply by 60 to get the number of minutes. Tamina, you don't need to ask 3 times. I saw you. So Angie, just to show you again, you work out the number of hours. So we worked out the number of hours by doing 120 divided by 52. And then I pressed this button here, which has a circle, a comma, and then a double comma. So the button on your calculator, what does that do? That gives you hours to hours, minutes, seconds. So Tamina, I converted this to hours and I got 138. And then you're thinking, how many hours is that? Well, that's got 120 and 18. So the 120 is your 2 hours, and the 18 is the extra 18 minutes. Okay, ready for the next one? I'm not going to have a break just yet. I'm going to have a break halfway through. Halfway through is going to be in about 20 minutes. Yes, 2 hours, 18 minutes is the final answer because we want hours and minutes to the nearest minute. Morpheus, genuine answer, half. The answer would be 2 hours and 18 minutes. Tamina, from the question, 52 kilometers per hour is the speed. All right, let's do this. Barry has 5 identical cone-shaped statues, as shown below. Find the slant length of the cone shown below. How do we do it? How do we find the slant length? Maybe later, Ibs. Very good, Kaula. It is going to be, well, we just want the length, right? Slant length means this. It is going to be Pythagoras. So we should draw a little picture, right? Notice we've got the height of the cone. There's our triangle, huh? So we're looking for this L. But what are our other measurements? Correct, Aisha. When it's tricky, draw a picky. Yeah, there it is, the right angled triangle hiding in plain sight. So what numbers do I put on my right angled triangle? Very good. That's going to be half of 1.4, which is 0.7. So the base is 0.7 and the height is 1.2. So how do we use Pythagoras' theorem here? What's my little to-do list for Pythagoras? I mean, before we do that, I like to label, right? A, B, C, label. Then write down a squared plus b squared equals c squared, and then 0.7 squared plus 1.2 squared equals L squared. Tamina, if you've seen these questions before at some point, you just get used to what you have to do. This is a classic thing. If you have the height of a cone, you find the slant length using Pythagoras. If you've seen it before, now you've seen it, you can't be fooled again. So 0.7 squared plus 1.2 squared. How do you think I know all of these tricks? I'm not that smart. I've just seen them before, like I've played these games before or something. So 1.93 equals L squared. So how do I find L? Yeah, but why my maths tutor? Because I've done all of these things before. I've spent a long time doing this. It's not just like I wasn't just born and then, the doctors looked at me and said, this one's a maths teacher, you know? So then square root of 1.93. 1.39. Nice. Units. Thank you, Mavis. Yes, Tamina. Cool. Now, number 2. The cones are to be painted. A tin of paint will cover 5 meters squared. Kayla, it doesn't really... Yeah, we did round up 1.39, no? Yeah, 1.389. I rounded it to 1.39. It doesn't matter too much here, to be honest. It's not telling us what accuracy we should use, so this will do. So, how many tins of paint? A tin of paint will cover 5 meters squared. How many tins of paint will be needed to paint all 5 cones? The area of the curved surface of a cone is pi RL. So what do we do here? Not quite, Tamina. Not yet. They are... Oh, excellent point, Kaula. It is a solid cone, and we want to paint the base as well. RTX on because it's a length. Lengths are measured in meters, not meters squared. So we want to find the surface of each one and then multiply by 5. So total surface area. Correct, Suleiman. Total surface area. Very good, Kaula. It's going to be the area of the circle on the bottom plus your curved surface, pi RL. What's the formula for the area of a circle? Pi r squared. Very good, Izzy. So it's pi r squared plus pi r L. So let's see. We've got pi r squared, which is shift pi. The radius is 0.7, right? Diameter was 1.4. Radius is half of that, 0.7. So pi r squared plus pi times radius, 0.7, times slant length. Now slant length, 1.39. So each cone has a surface area of 4.596. And this is each one, 4.596 meters squared each. So that means total surface area. Tamina, the curved surface of a cone is this one. It's like if you think about an ice cream cone, it's the waffly bit. Safi, the 0.7 is the radius of the base, right? From the center of the base to the edge of the base, because it's a circle. So what's going to be the total surface area we have to paint? Yeah, we've got 5 of them, right? We've got 5 cones. Each one has a surface area of 4.596. So I'm just going to take that 4.596 and multiply it by 5. Remember, use the answer button so you're not rounding, you're not having to write down numbers with a million decimal places. The total surface area we need to paint is 22.98 meters squared. Star Monkey, you will get the equation for the curved surface area. You don't get given the equation for the area of a circle. That one you do need to remember. So how many tins of paint are we going to need? Each tin of paint covers 5 meters squared. Doesn't make too much of a difference how, at this stage. How many tins are we going to need? We need 5. The way I got that is I multiplied by 5 because we have 5 cones. So we would need, that equation is given to me now, here it is. The area of the surface area of the cone is pi RL. So I'll do a little recap of what we did as soon as we finish the question. So each tin is 5 meters squared. So 1 tin, 5 meters squared. 2 tins, 10 meters squared. 3 tins, 15. 4 tins, 20 meters squared. 5 tins, 25 meters squared. So we need 5 tins. Exactly, Kaula. 4 tins won't cover it. 4 tins is 20 meters squared. 5 tins is 25 meters squared. That will be enough. So what did we do? We said the cones are to be painted. Now, that's generally a hint, right? They like these paint questions because paint needs to cover a surface area. So if you're talking about things being painted, you're definitely talking about surface area. A tin of paint will cover 5 meters squared. And you see this meters squared, and that's another hint that we're talking about surface area here. How many tins will be needed to paint all 5 cones? Well, we're going to need to find the total surface area of the 5 cones. So what we do is we find the surface area of each one, and the surface area of a cone, think about what's on the outside. It's a circle on the base, and then it's this curved surface on top. Now we found the area of one of them, multiply it by 5. That's the total area, which is 22.98. And then, to find the number of tins, we're going to divide that by 5 because it's 5 meters squared per tin. This is 4 marks, this second part, Ali. All right, ready for another one? If you're ready, say ready. All right, Maynard's ready, Rochelle's ready, Javera's ready, Hal's ready. Shout out to all of you that didn't hit subscribe, didn't join subscriber mode, can't comment. I don't see you, but I know you're there. All right, let's do it. Hello, Zane. Hello, Noor, Millie, Ali. Work out x to 2SF. What are we going to do here? Yeah, this is more Pythagoras. So, very, very quickly, how do we do it? No, no SOHCAHTOA, Maynard, because there's no angle. We don't care about angles. If we see no angles, it's going to be Pythagoras. The answer was 5 tins, bowlist. Because we need to cover 22.98 meters squared. Each tin was 5 meters squared, so we need 5, 10, 15, 20, 25 meters squared of paint, which is 5 tins. Label A, B, C. And then you write down A squared plus B squared equals C squared. So we know 45 squared plus X squared equals 85 squared. And now just make X the subject. X squared is 85 squared minus 45 squared. X squared is, should be naught. And if not, we'll do it at the end. Don't worry. 85 squared minus 45 squared. 5,200. And therefore X is square root of 5,200. We want that to two significant figures. Depends on your exam board, Rishol. For some people's exam boards, it won't have come up already. So I'm gonna, I can't remember if I put it in here, but I probably did. Shouldn't be long anyway. 72.111. What's that to two significant figures? With units. Two significant figures with units. Two significant figures is 72 centimeters. All right. Okay, ready for the next one? Aishi, you'll be given the formula for the volume of a cone, but it's 1/3 of pi r squared height. Let go. Why does x have to be b? Leon, it doesn't make a difference if it's a or b. Whether it's a or b, it definitely can't be c. C has to be the hypotenuse. So c is always opposite the right angle. I know Niharika. She did me a big favor. All good, I hope. Right. A town's population is 640,000 people, having grown by 16% in the past 3 years. What was the population 3 years ago? Elevate minds, just rewind. We had a bearings question right at the beginning. So what we think in here? Absolutely not, Rishol. We do not want to just decrease 640,000 by 16%. It's a reverse percentage, right? We have the final value, we want to find the initial. So this is a reverse percentage. So when you have, we need the multiplier, good. When you have final value and want to find initial, we need reverse percentages. So how do we do it? We're saying, what's the multiplier here? Grown by 16%. Donald, we don't even need to cube it because it says in the past 3 years. It's not saying 16% per year. It's just 16%. That's all. So it has grown by 16% means 100% plus 16%, which is 116%. Mayna, you know it's a reverse percentage because you have the final value. Ibs, this is how you find a multiplier. You add the percentage increase to 100% and then convert to a decimal. Oh, no need to apologize, Donald. So you add the percentage increase or subtract the percentage increase from 100% and then convert to a decimal. So this here is your multiplier. And then you know that the original value, let's call it x, give it a name. We know that x grew by 1.16 and gave 640,000, right? We're saying that essentially our unknown population and then this means grew by 16% and gave this. This was our final population. So how do I find what x is? It is going to be correct to say. So x is 640,000 divided by 1.16, right? You just turn it into algebra at this point. We're dividing both sides by 1.16. 640,000 divided by 1.16. 551724. Yeah, I mean, here I can just do it to two significant figures like the original number. 550,000 people will do to 2SF. But you can write out the whole number. It's not a mistake. Okay? So, the best way to do these reverse percentages is... Oh, greetings, Alara. Best way to do these reverse percentages is think about the original population, the original value as an x, just give it a name, call it something, and then imagine that that's been increased to give something. The reason you can't just decrease the final by 16% is that 16% of 640,000 is different than 16% of 550,000. Right? They're different numbers, so 16% of them is a different value. All right. Shall we say we have a 10-minute break? It's 6:51 now, so be back at 7:01. All right, 10-minute break. See you then. Do what you need to do. Go to the toilet, get some water, have a snack. See you shortly. Oh, Brownie Rose, why did I not put 3 squared with a multiplier? Why would I put 3 squared? You're confusing this with compound interest. If it was 16% each year, I would do the multiplier to the power of 3. But it's not 16% each year, it's just 16%. There he is. Greetings. How we doing? How we doing? How we doing? Are you there? If you're there, make yourselves known. I am back, Shannon. Carry on, carry on. Oh, thank you, Sapphire. Very much appreciated. Yeah. I won't start right away. What I will say though, guys, for some of you, this might be the last time you see me, right? It's been a nice year of maths, and this is the final session. Now, whether you're a regular returner or whether you're a new joiner just for this stream today, if you found this helpful, please let us know. Share it on Trustpilot. I think at the end, I think after this session, I mean, let me just go. There should be some information right at the end. Whew, loads of stuff. Yeah, so check your email at the end of this. Leave me a review. Let people know. If I've helped, then please let me know. I'd love to hear about it. If I haven't helped, I'm sorry, but you know, in any case, even if I have helped, you've put the work in. Yeah. This is all you're doing. I've helped a little bit, perhaps, but all the best of luck. Yeah, my headspace definitely does A-level Chizoba. All right, kids, should we continue? If you're ready, say ready. Greetings, Christian. Let's do it. Let's do it. Let's do it. Shout out to the mods as well, yeah? Each and every. Doing a tough job. We've got an hour and a half left. Trust God, bro. Yeah, so till 8:30. Let's go. Right. Javier cycles for 20 minutes at an average speed of 6 kilometers per hour, and then another 45 minutes at an average speed of 10 kilometers per hour. Calculate Javier's average speed for the whole journey. Very good, Tamina. We're going to need total time, and we need the total distance. So, what are we thinking? What's the total time? Careful, Tamina, read the question carefully. What is the total time? 65 minutes. Good. Very good. And what's the total distance? How are we going to find the total distance? We should break it up a little bit, right? No, it's not 16 kilometers. It's not 16 kilometers. This is a speed of 6 kilometers per hour. So let's call this stage 1. Stage 1, how far have you gone? You've done. Time is Tamina, because the time is 20 minutes and 45 minutes. That's it. There's no hour. You can make a table. Right. Here's what I would do, right? Again, it's the speed, distance, time formula. So speed equals distance over time. What's distance then? Rhoda, I just added 20 minutes and 45 minutes. Kaula, I do not, actually. So distance is going to be speed times time. Very good, Angie. So your speed is 6 kilometers per hour. Your time is 20 minutes. Now I can't use minutes with kilometers per hour. So how do I do it? How do I turn 20 minutes into hours? We were talking about this before. Wait, so 20 minutes times 60? Because Tamina, it's not 6 kilometers. It's a speed of 6 kilometers per hour. 20 minutes, you want to divide it by 60 to convert to hours. So, by the way, there are some standard fractions of an hour that you need to know. 20 minutes is a third of an hour because 20 is a third of 60. What fraction of an hour is 45 minutes? Like imagine your mate is saying, I'll be there in 45 minutes. What fraction could your mate have said? We'll get there, Elevate Minds. Yeah, it's 3/4, right? 45 minutes is 3/4 of an hour. So 6 kilometers per hour times 20 over 60, 6 kilometers per hour times a third. So that's 2 kilometers in part A. So total distance will be 2 kilometers plus in part 2, another 45 minutes at 10 kilometers per hour. So the distance here is going to be your speed, 10 kilometers per hour, times your time, which is 3/4 of an hour. What's 10 times 3/4? 7.5, correct. 3/4 of 10 is 7.5 kilometers. So what's the total distance? You did 2 kilometers in part 1 of the journey, 7.5 kilometers in part 2 of the journey, so it's going to be 9.5 kilometers. So now to get the speed in kilometers per hour, so total average speed rather, from the question short facts, there is 10 kilometers per hour. Very good, Izzy. So average speed is 9.5 kilometers divided by how many hours? Well, the hours is 65 divided by 60. Divide by 60 to turn the minutes into hours. So 1312, so 1.08333. So it's 9.5 divided by 1.08333, which is, if you use the answer button on your calculator, you can just go 9.5 divided by answer. 8.77 kilometers per hour. Ibs, if you just search Casio emulator, you should be able to download it. All right, ready for the next one. So, average speed is total distance divided by total time. You need to use the speed distance time formula to find distances. Ladybug, I recommend you rewind, watch it back. We have quite a few questions to go through that I think you'd all benefit from. So I'd like to move on. But if you're still stuck, probably stay a little bit at the end for questions and that. So it's not a problem. Right, on the centimeter grid, draw an isosceles triangle with an area 16 centimeters squared. Maria, I had 65 minutes. I divided it by 60 to get the number of hours. I keep on forgetting, Ibs. Don't worry, it will happen. It will happen when you're least expecting it. How do we do this? What's the meaning of an isosceles triangle? Two sides are equal. Thank you, Donald. Yeah, almost. Now, the area is 16. So what does that tell us? Two sides are equal. How do we find the area of a triangle? Area of a triangle? Half times base times height. Very good. And that's supposed to equal 16. So if half times base times height is 16, then base times height is going to be equal to 32. So you just need to find two numbers that multiply together to give 32, 4 and 8. So here's your height, 4. Your base will be 8. And here is your triangle. It's isosceles because those two sides are the same. We have a base of 8 and a height of 4. So we just need base and height to multiply to give 32. Cool, nice, simple 2 marks. Ready for the next one? Haroon, I don't like to do predictions. It's good to just have all skills. I've tried to include a bit of everything. So Angie, we're saying if the area is 16, then 16 is half times base times height. So if half times base times height is 16, then that means that base times height is going to be 32, right? Because if you halve it, you'll get 16. So we're looking for two numbers that multiply together to give 32. I don't know, let's do 4 and 8. We could also have done 2 and 16, but we don't have enough squares on our grid. Right? We could have done all sorts of stuff, but we do the ones that fit on our grid. Does that help? Angie, or anyone else who was stuck? All right. The kids are ready. Let's go to the next one. Hey, love these. Diagram shows an isosceles triangle with the sides extended. Find the size of angle HCF. First of all, where is angle HCF? What the? Have no fear, Haroon. What I do with questions like these is I just work everything out, right? I don't even think about what I'm trying to find. I just find everything. HCF, okay, so HCF, this is our aim. This is the angle we want. But to get that, we're going to need to find everything else first. Don't be scared. Just break it down. All right, Khawla's found one already. 180 minus 156. Right, angles on a straight line have to add up to 180. So that's got to be 24. What next? Right, that's 1. So to find that, we used angles on a straight line. Number 1, we used angles on a straight line. Then, okay, very good. We now have an angle in an isosceles triangle. So the other two, exactly. So these two plus 24 add up to 180. So each of these, excellent. Juverius spotted another one. We've got some zangles going on. So ECD is also 24. Let's call that number 2. What's the proper name for Zangles? Alternate, very good. Alternate, not alternative, alternate angles are equal. Nice. And then what about the red ones? Amal, Zangles are angles that sit on a Z between parallel lines. So I mean like this, 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 then this angle and this angle I would call Zangles. Right, for the red angle, I use angles in a triangle. Excellent, Kaula. So these are going to be 180 minus 24 divided by 2, which is, what's that? That's like 78 degrees. And this is 78 because isosceles. And therefore, oh, wow, we can find the aim now. So what's the answer? It is 78. We're going to go angles on a straight line, 180 minus 78 minus 24 equals 78 degrees. Job done, right? We've got angles on a straight line. We've got 24 here. We've got 78 here. What's left? 78. Angles on a straight line. Wicked. So don't be afraid of these questions. Just start working stuff out. Draw all over your diagram. By the time you've done a question like this, your diagram should be absolutely defaced. All right. Ready for the next one? Right. Just keep rolling. Ready to rumble. Let's do it. A tile is shaped like a rectangle. An 8-sided shape is made from 3 copies of this tile as shown below. Work out. Was the last rule corresponding? It wasn't, Tamina. The last rule was just on a straight line. An 8-sided shape is made from 3 copies of the tile as shown below. Work out the perimeter of this shape. What do we think? What do we do here? First of all, what does perimeter mean? Right. Add the distance around, breaking it down. Correct, Juveria. Correct. Add distances around the edge. So we can see all sides added together. I've got a 5 here. I've got a 5 here. I've got a 5 here. Got a 5 here. Anything else I can add? Haroon, we don't want the area because it's only asking for the perimeter. So we're not going to waste time finding the area. That's not going to help us. The long sides are 8. So here's an 8. Here's an 8. Here's an 8. Here's an 8. Are we done? Have I taken into account all sides? No, why not, Christian? What are we missing? What are we missing? What are we missing, guys? Yeah, I need this. And I need this. What's the length of those? It's not half of 8. It's 8 minus 5, right? Remember, this is up to here, it's 5. So this is going to be 3. And this is going to be 3. So what have I got? 3 plus 5, 8. Plus 8, 16. plus 521, plus 829, plus 332, plus 537, plus 845, plus 550, plus 858 centimeters. That's what I'm getting. Double check, please. Let me know if I'm wrong. Nice. All right, ready for the next one. So just mark them all on. Add them all together. 5 plus 3 plus 8 plus 5 plus da da da, and so on and so on and so on. 58 centimeters. Nice. Are you ready to rumble? Which other 5-piece for piece? Oh, absolutely. Thank you, Donald. Good to know. No, I don't add this one because this one is an inside edge. I don't add that one on. I wrote it down to make sure. No, Haroon, because we've asked for perimeter. Since we ask, what would the area be? Don't add that extra 5 inside. What would the area be? Just in case they asked. Right, each one is 8 times 5, each one's 40, so we've got 40 here, 40 here, 40 here, so total area is 120 centimeters squared. Notice, perimeter, centimeters, area, centimeters squared. Yeah, so different units because they're different things. An area is an area, a length is a length. All right, let's do it. Perimeter, you don't add anything on the inside, no piece for piece. Okay. Oh, lovely bit of Venn. The everything set is 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah, that's right, Izzy. Set A is 2, 4, 7, 9. Set B is 1, 4, 8, 9. Complete the Venn diagram to show this information. How do we do it? Oh, some people are happy with this one. How do we do it? Place numbers in the diagram. All right, how do we begin though? Put the things in the middle, right? Anything that is in both. Yeah, 9 goes in the middle. Anything else in the middle? Four also goes in the middle. And then the rest, A also has a 2 and a 7. B has a 1 and an 8. Are we done? No, we're not. What else? Right, everything on the outside, right? So we've done 1, we've done 2, we've done 4, we've done 7, we've done 8, we've done 9. We haven't done 3, 5, or 6, so we've got to have a 3, a 5, and a 6 on the outside. Okay, number 2. So number 1, done. 3 marks, 3 easy marks. Find the probability that a randomly chosen number in the universal set is in the set A and B. Now, what is the set A and B? Correct, Rishol. What's the proper name for this? A and B. It's the middle only. It's called the intersect. The way I remember it is that this is n, like rock, n, roll. Yeah, like rock, n, roll, or I don't know, fish, n, chips. It means and. So if it's A and it's in B, How many are in A and B? Ali, U means or. So I'll put that in brackets down here. So A or B. Correct, it's 2 out of 9. So the intersect, that's 2 of them out of 9. Yeah, so 2 numbers out of 9 total. Okay, what about find the probability number 3? The probability that a randomly chosen number in set A is also in set B. What do we think here? The probability that a randomly chosen number in A is also in B. Now, here we need to think it's not 2 out of 9 because since we're going just based on the numbers in A, we need to go out of the ones in A. How many numbers are there in A? I mean, in A, there are 1, 2, 3, 4 numbers, right? It's 2, 4, 7, and 9. So it's out of 4. Now, out of those 4 numbers in A, how many are also in B? It's 2 out of 4, correct, D. So 4 are in A, and 2 are also in B. So it's 2 out of 4. Also known as, never forget my allergy. Two over 4 is also known as 1/2. So Tamina, you know that 4 is the denominator because it's talking about a randomly chosen number in A. So your denominator is going to be out of how many there are in A. The allergy never went away, Rishol. All right. Ready for the next one? Mm-hmm. I see you, Beans. Let's do it. Here is an inequality. Solve the inequality. All right, what do we think? Let me write it out so we know what we're doing. Nice. I wouldn't start with multiplying by 3, Tamina. What's furthest away from x? Start with subtracting 5. So subtract 5 from everything. 2 minus 5 minus 3. 6 minus 5, 1. Now what? Now multiply everything by 3. Get rid of that denominator. Oh, because we're trying to get Aisha, we're trying to get the x on its own. So we need to strip everything away from the x. And the way I always think of it, Tamina, is like socks and shoes, right? Whatever's closest to the x is like a sock. Whatever's further away is like a shoe. Now you take off shoes first, right? Because you haven't taken off your shoes, you can't get to your socks. Nor. Sorry, no, not nor. D. 2 minus 5 is minus 3. Then I want to get rid of that division by 3 there. So I'm left with 2x. And 2x is 1 times 3, 3. Minus 3 times 3, minus 9. Now what? Correct, Amina. If you're trying to simplify and trying to get x on its own, start with the things on the outside first and then work your way inwards. Now divide by 2. Very good, Rishol. Doop, doop. So x is going to be less than 3 over 2 and greater than or equal to minus. What's half of 9? Venn, this is algebra. Inequalities. What's half of 9? 4.5, thank you, Hal. In fact, half of 3 is 1.5. Okay, that's it. That's my inequality solved. 3 nice marks. Now, how do we show this on a number line? What does this actually tell us? Boxer, there's about 30. We'll see what we can get done in the time. Now put it on the line. How? Well, this is telling me that x can be between minus 4.5 and 1.5. So x is allowed to be here, but we need to make sure that we show the right thing exactly. It includes minus 4.5. It does not include 1.5. So, very good, Donald. This one would be shaded in because if it's shaded, it's included. Can be here. Include minus 4.5. And this is exclude. No, Venn, this is foundation. Ready for the next one? So remember, if it includes the limit, it's shaded in. If it doesn't include it, it's empty. Right. Another wordy one. Joseph is setting tables for a wedding. There are 14 tables. On each table there are 2 vases, and each vase should contain 6 flowers. The florist sells bouquets of 15 flowers. Each bouquet costs £16.70. How much will Joseph have to spend to set the tables as he should? What are we thinking? Okay, very good, Izzy. So, remember, tell a story, narrate your calculation. What are we doing first? What are we going to try and work out? That's not the way I would go, Christian. What do we think? Yeah, I would. How would we begin? You wouldn't just randomly multiply all the numbers together. Let's think. Yes, this is being recorded, Hermela. Okay, good. So, think about how many flowers are needed. Bye, Mavis. So the number of flowers needed, we've got 14 tables. Each table has 2 vases. So we've got 28 vases, 14 times 2 vases. Each vase has 6 flowers. So we've got 28 times 6. Right, you've got 28 vases in total. Each vase has 6 flowers, so 28 times 6 is 168 flowers in total. So, how much would we have to spend to buy 168 flowers? Correct. 168 divided by 15. Well, Tamina, we're not going to buy 168 bouquets, right? We want to buy, each bouquet has 15 flowers, so we're probably going to need less than that. Good, Angie. So 168 divided by 15 gives us what? That's how many bouquets we need. 168 divided by 15. So we're going to need 11.2 bouquets. Aisha, not times, because look, we need 168 flowers, and we need to get that in bunches of 15. Okay? So we need to think about how many times 15, how many lots of 15 there are in 168. So exactly, Safi, you can't have half of a bouquet, so we're going to need to buy 12 bouquets. If we buy 11, we're not going to have enough. So we need to buy 12 to make sure we have enough flowers. And then, I don't know, maybe the extra ones at the end, we just keep for ourselves or like give them to our mate or something. So we need to buy 12 bouquets. If we buy 11, we won't have enough flowers. So what's the cost? Nice. It's going to be 12 bouquets times 1670, which is £200, 4E. Nice. All right. Are you ready, kids? Nice. God, you guys too young even for SpongeBob SquarePants. Oh, finally. Yeah, let's do it. Go on then. All right. Roger that. Green Hill Giants score the following number of points in their first 16 games of the season. Work out the mean number of points Green Hill Giants score per game. How do you do this? Yes. Yes, yes, yes. So how do we do it? Add them all together, divide by how many there are. So 0 plus 0 plus 0 plus 0. In fact, just do it like this. 0 plus 0 plus 0 plus 0 plus 1, 1, 1, 1, 2, 2, 2, 3, 3, 4, 5, 5, 28, and divided by, we don't even need to count them because they've told us it's 16 games, but just in case there's a typo, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Indeed, it's going to be 28 divided by 16, 7/4, which is 1.75. We've got a bit of a dispute. Can everyone just double check? Is it 1.75 or 1.875? Check again. Check again. So what did I have? I had 0 plus 0 plus 0 plus 0, and then I had 4 ones. 1, 2, 3, 4. Ooh. 1, 2, 3, 4. And then I had 1, 2, 3 twos. 1, 2, 3s. A 4. 1, 2, 5s. Oh, it is 30. You're all right. 1.875. My bad. Thank you, thank you, thank you. Number 2, find the median number of points. How do I find the median number of points? What does median mean? It's the middle value. So because they're written in order, we just cancel them from the outside. Exactly. They're already arranged. So first and last, second and second to last, third and third to last, fourth and fourth to last, fifth and fifth to last, sixth and sixth to last, seventh and seventh to last. We end up with 2 in the middle. So what do? Medians, is it 1 or is it 2? What do? Correct, Donald. It's the 8.5th number, which is the halfway between 1 and 2. It's 1.5. Halfway between 1 and 2. Correct. And what about the range of the points? Add them and divide by 2 exactly. 1 plus 2 divided by 2, which is 3 divided by 2, which is 1.5. The range of the points, largest minus smallest, so it's 5 minus 0, which is 5. Okay. Their rivals, Brookdale Bears, score a median of 2 points per game with a range of 3. Compare the distribution of points scored by the two teams. What do? Here, you literally just have to state, okay? So, let's just get them all in one place. Green Hill Giants, we have a median 1.5 and range 5. Brookdale Bears have a median 2 and a range of 3. So what can we say? I would say something like Brookdale Bears tend to score more goals, tend to score more points. Guys, can we log back in, please? I'm losing them. The Brookdale Bears tend to score more points, but the Green Hill Giants have more variation, right? Because they have a bigger range, which means sometimes they score lots more points. So that's enough. Okay, I think there's a few people that are lagging behind a little bit. Please try refreshing just to catch up. So if you're comparing data sets, that's all you need to do. Nah, Leon, we can power on. Are you ready for the next one? If you're ready, say ready. Yeah, next question. Kaola's ready, Safi's ready, Hal's ready, Rox is ready, Aisha's ready. Donald, let's do it. While on holiday in Italy, I go to a restaurant. The meal costs 36 euro. If I pay in pounds, the restaurant converts the cost at a worse rate of £1 is €1.20. If I pay in euros, my bank uses the exchange rate £1 is 1.2437, but charges an additional 3% fee. Calculate the difference in the total cost in pounds between paying in pounds and paying in euros. So, how do we do this? Let's do it for each one. Pay in pounds. So, Mere Pudi, it's based on past paper questions. Okay, good. Pay in pounds, 36 euros. Now, each pound is €1.20. So the first thing that I do is I do a little diagram, right? £1 is equal to €1.20. So I know that if I'm going from pounds to euros, I multiply by 120, which means that if I'm going back from euros to pounds, what am I doing? I'm dividing by 120. So 36 euros is going to be 36 divided by 120 to get it into pounds, which is £30. Bye, Samuel. So let's work out what it costs to pay in euros. Euros. So again, if we're going from pounds to euros, we're multiplying by 1.2437. But if we're going the other way, we're dividing by 1.2437. So if you pay in euros, the cost is going to be 36 divided by 1.2437. Manar, we've got another 45 minutes-ish. Which is, let's see, 36 divided by Izzy, that's absolutely correct. 1.2437, 28.9695 is the basic cost. And then increase by 3%. How do we increase this by 3%? Very good, Tamina. That means the multiplier is 103%, which is 1.03. So it's going to be 28.95 times 1.03, which is answer times 1.03, 29.81. So what's the difference in the cost? It is just 19p, right? 30 minus 29.81 equals 19 pounds. Be careful, don't call it 0.19p. It's 0.19 pounds or 19 pence. All right. I'm sensing that some of you are flagging a bit. 5-minute break. Or move on. Five-minute break. 5-minute break. So back at 7:54. That's 5 minutes precisely. Let's do it. 5 minutes, right? But strict 5 minutes. One's already gone. I understand it's the end of exam season. It's been long. Hello. Hello, hello, hello. 7:54. Time for a little bit more. If you're ready, say ready. Final push. Come on. Let's do it. Okay. Next question. Maya, Ben, and Lucas share a sum of money in the ratio 7:5:3. Ben receives £100. Maya then gives some of her money to Ben and some to Lucas, and the money that Maya, Ben, and Lucas now have is in a ratio of 4:6:5. How much money did Maya give to Lucas? How do we do this? Now, to begin with, I'd figure out how much money is available at all, right? So how do we do it? I see lots of different methods here. Exactly. I would say £100 equals 5 shares, which means that one share is how much? So we know this is Ben. Very good. So one share is 20, which means that to begin with, we have, let's see, what's that? 7 times 20, so that's 140 to 100 to 60. Maya then gives some of her money to Ben and some to Lucas. The money that Maya, Ben, and Lucas now have is in a ratio of 4:6:5. So how do we do this? I guess, Millie, we're about 2.5 hours in. So skip to like 2 hours and 20 minutes. Okay, so total money available is 140 plus 100 plus 60. No worries, Millie. All the best of luck tomorrow. Which is what? That's about £300. So what we do now is we figure out how it's the same amount of money, right? No money leaves the system. It's not that straightforward, Donald, because we might not have the same number of shares as before. So it's better to figure out exactly. So now we have 15 shares after 4 plus 6 plus 5. That's correct, Juliana. And so £300 divided by 15 is once again £20 per share. So how much money did Maya give to Lucas? Well, before, Lucas had 60, and after, Lucas had 5 times 20, which is 100, which means that Lucas got 40. So what do? We first of all figured out how much money there was to give out, and then we split it again in a different ratio and figured out how much money Lucas had gained. All right, ready for the next one? Juliana, I think it is coming up. And if not, I'll talk about it at the end. Right, ready. All right, a sports store has 2 different special offers on tennis balls. And these are quite common in paper 3. comparing value. So let's see, which offer gives better value for money? You must show how you get your answer. How do we do it? So store 1, pack of 3 balls, £1.50, buy 2 packs, get 1 pack free. Store number 2, pack of 6 balls, £2.70, buy 1 pack, second pack for half price. Okay, very good. So for the first store, cost for the offer, you buy 2 packs, so that's going to be 2 times £1.50, which is £3. And how many balls do you get? That's going to give you, well, it's a pack of 6 balls, and we're getting 2 packs and 1 pack free, so 3 packs of 3 balls, so that's 9 balls. All right, shop number 2. Buy 1 pack, get the second pack for half price. So if we go for the offer, how much are we paying? Cost. Javeri, is that the bulldog? Oh, yes. So what's the cost here if you take the offer? Okay, we get 12 balls for sure because we get 2 packs. But the cost is you buy 1 pack and you get a second one half price, which is £3. No, sorry, that's £4.03. £4.05 for 12 balls. So which is a better deal? We've got £3 for 9 balls, or £4.05 for 12 balls. How do we do it? How do we figure out which one's cheaper? Divide. We want to divide it down to be comparing the same number of balls. Yeah, convert how much for 1 ball. 1 ball is going to be divide by 9. So it's going to be 3 divided by 9, which is... Devang, we finished the teaching, but we're doing a revision at the moment. Yeah. Thanks for dropping in. So this is £0.333 for 1 ball. Whereas here, we divide by 12 to get to 1 ball. 405 divided by 12. Ooh. 405 divided by 12 is 3375. So this one is cheaper. Offer A is cheaper because each ball costs less. All right. Devang, we did it earlier. That's why. It was rescheduled to 4:20 because I'm doing this. Ready for the next one? I don't understand your question, Tamina. Okay, table of values. Well, it depends on the offer, Tamina. Okay, table of values. So what do we do? Here's what I do with table of values. I mean, I've shown you this already, but I'm going to show you again. Make the function in your calculator instead of x, or put it on table, or just do it yourself. So the way I do it is I construct the function, I write it down exactly as written, and in place of x, I've got brackets. So minus a quarter, and then open brackets, close brackets, that's my x cubed plus open brackets, close brackets, squared minus 1. So then I start with minus 2, minus 2. That's 5. So first one is a 5. Next one. Guys, can we focus please? Lock back in. It's been a long month. And it's only the 10th. With 1, right, you just replace what you've got here in your brackets. A quarter, which is 0.25. And then for 0, Lola, I always would. I always would use brackets because it just makes sure that we don't make any mistakes when it comes to negative numbers. Thank you, Kaula, voice of reason. It's just maths. Replace the 0 with a 1. Look how easy it is. You just replace the numbers. Minus 0.25. With a 2 here, we're going to have a 1. Double check the brackets, Safi, right? So it's very common with negative numbers to make a mistake. So you just want to be super, super careful. Do your substitutions in brackets always. If you've got 3, then that becomes 1.25. And then with a 4, we've got minus 1. So let's see what we get. Minus 2, 5. Minus 1, 0.25. Now, in order to plot the decimal ones, how much is each small square here? Very good, Callum. 0.2, right? We're going up in 5 steps to 1, so each one is 1 divided by 5, which is 0.2. So 0.25 is going to be just a little bit beyond that. Here it is. Then 0 minus 1. 1 minus 0.25, about here. 2, 1. 3, 1.25. 4, minus 1. What type of graph is this, guys? This is one of the types of graph that you need to know about, and it's not quite a smiley face. It's a little bit jankier than that. Look what happens if you join up bent one, dolphin. What's the name for this kind of function? It's a cubic. Well done, Hala. Well done, Donald. This is cubic. Well done, Ali. Well done, Callum. This is a cubic graph, right? Something like this. Then, by drawing a suitable line, estimate the roots of the equation. How do we draw a suitable line? How do we draw a suitable line? Y equals, thank you, rocks. We've got y equals this stuff, and we want to intersect it with y equals 0.5. What does y equals 0.5 look like? Horizontal line at 0.5. So here it is. Exactly, mark it on the graph. You've drawn a suitable straight line. So now, finally, how do we estimate the roots? Judy, we've got cubic, quadratic, reciprocal, linear. Right, go back to cram session number 2, where they cross. Very good, Callum. I talk about them in cram session number 2. I'm not going to talk about that right now. So here is one root, about -1. Here's another root. I'd call that about 1.6. And here is another root. Let's call it about 3.3. Yeah, that's why, Kaula, that's why it says roots, because there's lots of them. Yeah, there might be more than one, and that is fine. Equations can have more than one root. Correct, Amina. Roots is where they cross the x-axis. Or if you're finding the roots of an equation, it's just where the equation is solved. Yeah, that'll be nice, Callum. All right, ready for the next one? We're in speedrun mode now. So paper 2 and paper 3, especially for Edexcel, are often quite similar, right? There's not really much difference in the kinds of questions that come out. So if you want more, you can always go to my paper 2 cram. All right. Some nice easy marks for you. Library has 570 books in total. The books are either fiction, non-fiction, or reference books. 3/10 of the books are fiction, 200 of the books are non-fiction. What percentage of the books are reference books? Uh, Safi, what you mean in the table of values with the minus signs? Look, here's the way I would do it, right? You've got the equation written out here, -1/4, something cubed. So I put in -2, but making sure that the -2 is in brackets, because if it's not in brackets, you might end up making a mistake. And I get a 5. That's how I do it. So try the same thing with the other one. It's for everything, Bolist. So let's find 3/10 of the books. That means it's 3/10 of 570. Correct. Of means a multiplication, so that is, what's that? 171. 200 of the books are non-fiction. Okay, that's 200. So reference books is 570 minus 200 minus 171, which is 570 minus 371, which is 199. So this is all books. The 200 is the non-fiction. This is the fiction. So you've got 199, and then what percentage? How do I find then what percentage are reference books? It's going to be correct, Kaula. It's going to be 199 divided by 570, 199 out of 570, multiplied by 100, which is 34.912%, or to the nearest percentage, 35%. Right, easy marks these questions, comparing fractions, percentages, decimals. Not long. Right, if you're ready, say ready. kicked up a gear here. When does it end? Right, it ends in about 15 minutes officially. Probably going to stay a little bit longer for those that want. Very nice. In the diagram below, find the value of the angle x. So what are we thinking? Yeah, guys, it's been long. Okay, what are we thinking? Not maths color. I won't be doing A-level maths. Angles around a point add up to 360, but how are we going to do this? What kind of shape have we got here? It is interior angle. Very, very good. It's not a rhomboid. It's a pentagon, right? We've got 1, 2, 3, 4, 5 corners, so we've got a pentagon. So, what is the total interior angle? Total interior angle is 180 times n minus 2, which is 180 times 5 minus 2, which is 540. So we need to think what we've got. We've got 90 degrees here, 90 degrees here, 34 degrees here. What's this angle? Correct, 360 minus 90, this is 270 degrees. So we know that if we call this y, then 540 is going to be, it's not regular to Mina, so we can't divide by 5. Each angle is different. Instead, what we can do is say 90 plus 90 plus 270 plus 34 plus y equals 540. So now let's see, that means that y is going to be 540 minus all of those things. Get out the calculator again. 540 minus 90 minus 90 minus 270, 34. So y is 56. And therefore x is 180 minus 56, which is 124 degrees. Nice. All right. Straightforward marks for that one. Ready for the next one? 540, trust God, bro. It's from the total interior angle of a polygon. We have a pentagon, which means 5 sides. Right. Oh, the gift that keeps giving. H, that was 360 minus 90. Right, round the point, we had a right angle. Absolutely, Callum. That's exactly what I do. Always just work out whatever angles you can and then use angle rules. Ready to brumble. Right, what do we do here? Okay. I would figure out which side the x's need to go on. Which side do we want the x on? We always put the x's on the side with more x to begin with, which means we need to add 2x to both sides to begin with to get rid of x from the right. So 4x plus 2x, 6x minus 22 equals 5. Then add 22, 6x equals 27. Divide by 6, divide by 6. X is 27 over 6, which is 4.5. All right, nice light work. Right, you always want to move the x to the side that has more x to begin with, just to avoid negative numbers. All right, want to avoid negative numbers as much as we can. Ready for the next one? Let's do it. Guys, you've done a great job. Some of you have been in 3 cram sessions. A lot of you have been in all 3 cram sessions. That's deserves a medal. High level of stamina. Right, in the shape shown, lines BD and AE are parallel. So let me just add my little arrows of parallelicity. Given that AC is 24 centimeters, BD is 9 centimeters, AE is 14 centimeters. Calculate the length AB. What are we thinking? Not Pythagoras, because there's no right angle to Mina. All right, Shannon, but I'm sure you won't. Separate triangles, very good. These are similar shapes, so we want to say triangle 1 and triangle 2. So triangle 1 is BDC. Triangle 2 is AEC. Here is 24. Here is 14. So, very good, Cowler. To go from 9 to 14, or to go from 14 to 9, because we want to go from 24 to something else, we need to divide by 14 to get it down to 1, and then multiply by 9 to get it up to 9. So the 24 is going to be divided by 14 and then multiplied by 9. Exactly. Essentially, you want to find a scale factor, but I like to do it in this way, by thinking about how to get from one number to the other. To get from 14 to 9, we divide by 14 to get down to 1, multiply by 9 to get up to 9. So we take our 24, divide it by 14, multiply it by 9, we get 15.43. So similar triangles just means that corresponding sides are in the same ratio. So whatever you do to go from AE to BD, you have to do to go from AC to BC. Have we answered the question? No. How do we answer the question? Excellent, Philip. So AB is going to be AC minus BC. Exactly. It's going to be 24 minus 15.43. Philip was there first. It's 8.57 centimeters. Done. Very nice, Donald. Right, guys, faith in yourselves. Yes. You see a scary looking question. It's usually simpler than you think. You just need to overcome your fear and attack it. Ready for the next one? Guys, you've done like 5 questions in 10 minutes. Smashed it. Let's keep going. Keep up this pace. You're doing so well. Yeah. Onward, children of maths. Okay. The graph shows shapes A, B, and C. Describe the single transformation from shape A to shape B. What do we think? What type of transformation will take us from A to B? It is an enlargement. Good. Well done, Safi. We need the scale factor as well. It's an enlargement, scale factor times 2. And there's one more bit of information that we need. So we know it's a scale factor of 2 because you see this side that was 1 is now 2. And this side that was 2 is now 4. So all the sides got twice as long. But how do we find the center? So to find the center, you need to draw lines through corresponding points. That means this, for example, corresponds to this. So you find, here's a line that goes through those. You then, exactly, join each corner to its corresponding corner. And if you do that, you will find that they all cross at a point. So that is my center of enlargement. So what are the coordinates of that center of enlargement? X coordinate is 2, Y coordinate is 6. Nice. Describe the single transformation from shape A to shape C. What do we think here? Very good, Izzy. It's not a translation. Because look, if you move A over C, it won't sit over it. Right? That would be a translation. It's not a translation. It's a reflection because it's the other way around. But how do we find the reflection line? So the best way, if you can't see it immediately, and maybe you can see it immediately, but if you can't see it immediately, you once again, you join corresponding corners with a line, and then you cut that line in half. Here we go. Here's another pair of corresponding corners. Cut that line in half. Here's my mirror line. So the mirror line is exactly halfway between corresponding corners. So what's the equation of that blue line? X equals -1. Nice. Next, translate shape C by the vector 2, -3. Label this shape D. How do we do that? How do I translate shape C by the vector 2, -3? Move it to the right by 2, so it's 2 right, and then it's 3 down. So do it point by point, right? Take this point, it goes 1, 2 right, and then 1, 2, 3 down, and it ends up here. This point, 1, 2 right, 1, 2, 3 down. This point here, 1, 2 right, 1, 2, 3 down. And this point up here, 1, 2 right, 1, 2, 3 down. Here is my new shape D. So as you can see with all of these transformation questions, the key thing is the corners of the shapes. If you can figure out what's happening to the corners of the shape, you figured out what's happened to the shape. Ready for the next one? Oh, guys, I'm so proud of you guys. Really, really smashing it tonight. Let's go. Right, 4.71 times 10 to the 3 as an ordinary, by Cody, as an ordinary number. How do I write that as an ordinary number? Very good, Donald. So write it, 4.71. Imagine the decimal point is jumping by 3 places. 1, 2, 3. So it's 4710. B, write 0.000729 in standard form to 2 significant figures. How do we do that? Bye, Zane. Okay, so standard form to 2 significant figures. So it's going to be based on 7.29, but to 2 significant figures, your 7.29 actually becomes 7.3. Nah, Zane, if you pass, it's up to you. And then we need to think about how many decimal places the decimal point moved by. 1, 2, 3, 4. Except it was a small number, so it's 10 to the -4. So 7.3 to 2 significant figures times 10 to the -4. Finally, work out 1.6 times 10 to the 8 plus 8 times 10 to the 7. I mean, there's an easy way and a hard way. The easy way is put it in your calculator. But I'm going to show you how to do it without a calculator. What's the problem with trying to add these? The problem with adding these, because some people might still have, I don't know, maybe some people want to know. Okay, let's find what we're aiming for. Good point. Why do it without a calculator when you have a calculator? 1.6 times 10 to the 8 plus 8 times 10 to the 7. Okay, it gives you something. The problem, Aisha, you are correct. The problem is that we have different powers of 10. So the way you do it is convert them both to the same power of 10. So the way I do it, essentially, I'm borrowing a 10 from the 10 to the 8, so I can turn it into 10 to the 7. And then this becomes 16 times 10 to the 7 plus 8 times 10 to the 7, which is 24 times 10 to the 7. Once you've got the same power of 10, you can just add them. And then to make it standard form, we once again pull out a 10 from the 24, and that becomes 2.4 times 10 to the 8. Or you just do it with your calculator. Okay, I'm going to skip over the next one because we had a few money ones. If you want a little challenge, this question 30 is harder than what you'd get in an exam. I mean, I don't know what I was thinking. It's here. It's in the workbook. Poly, you can, but that's long. It's easier to do it in standard form with the same power of 10, but of course you can turn them into normal numbers and add them together, but then you'll have a lot of zeros to keep track of. When there's a lot of zeros flying around, it's a high probability of mistakes. So I'm not going to do this. It's in the workbook for anyone who wants a bit of fun. But this one, important. The picture shows two similar cylinders. The surface area of the small cylinder. All right, it's 8:30, right? This is the second to last question. Basically, it's this question about surface area and volume, this question about frequency tables. If you need to go, by all means go. I'm going to finish off these last two questions and stay for a few minutes if anyone has things they want to specifically ask about, things they're specifically worried about. If you are leaving, no worries, Samuel. Take care. Yeah. Anyone leaving, all the best. And yeah, please leave me a review if I've helped. If you've been here all year and you felt I've been helpful, please leave me a review. Say so. I always appreciate it. Puts a smile on my face. And in any case, all the best of luck tomorrow. Like I said, I'm staying. Picture shows two similar cylinders. The surface area of the small cylinder. Oh, Aisha, I don't have the answer on me right now. Can check it after. The surface area of the small cylinder is 45 centimeters squared. The volume is 25 centimeters cubed. So area is 45 centimeters squared, and the volume is 25 centimeters cubed. The larger cylinder had a volume of 120 centimeters cubed. Find its surface area. So, how do we do this? Bye-bye, JJ. Bye, Kaula. All the best. All the best of luck. I'm sure you're going to smash it. You're all going to smash it. Okay, very good. Similar shapes. So what should we be doing first of all? Find a scale factor. So we have volumes. Let's find the scale factor for volume. All right, Philip. Thank you, Juveria. The scale factor for volume is going to be 120 divided by 25, which is multiplying by 4.8. Bye, Kian. So what's the scale factor for area? It is not just 120. It's not just 45 times 4.8. How do we do it? So we want to keep track of things. Scale factor for volume is 4.8. There are different. Kian, I don't want to talk about grade boundaries because I don't want to jinx it, I'm afraid. There are different scale factors for volume, for area, and for length. So we need to, it's not divided by 2. So we want to go back to the scale factor for length. Now, remember, the scale factor for volume is the scale factor of length cubed. Exactly, Tamino. We need to cube root. So the scale factor for length is going to be the cube root of 4.8. So cube root of 4.8. So we go to our calculators. We go shift cube root 4.8. 1.6869. And then the scale factor for area is the scale factor of length squared. All right, because to get an area, you have to square a length. So we take our number that we just found and we square it. That gives 2.8455. And by the way, as a hint, we want the answer to 3 significant figures. So before we get to the final answer, we always want 4 significant figures to make sure that we don't make any rounding errors. We want more accuracy than the final answer in all of our working. So we work to 4 significant figures and then round at the end. So we're going to multiply by 2.8455. Oh, what am I talking about? That's 5 significant figures, even better. So then go back to my calculator and I go 45 times answer. Oh, whoever was saying 128 from the beginning, absolutely correct. 128 centimeters squared. Cool. All right, the final question. Ready? Nice to see so many of you still here. I salute you. The table shows the ages of 100 visitors to a museum. Which is the modal class? Bolist, because if you have, think about how you convert between centimeters and centimeters cubed, yeah, from meters and meters cubed. Centimeters and meters is a factor of 100, whereas centimeters cubed and meters cubed is a factor of 100 cubed. Right, same thing. Modal class is the one with the highest frequency. So what's the answer? The modal class is not 30. The modal class is this. It's what goes next to it. So it's the ages of 20 to 35. In which class is the median? How do we find the median here? Very good, Tamino. The middle number. In fact, we don't even need to add the frequencies because the question tells us what the total frequency is. We have 100 visitors, so n is 100. Exactly. So the median is the 100 plus 1 over 2th number, which is the 50.5th person. So essentially, you want to find how old is the 50.5th person. How do we do that? How do we find where the 50.5th person is? How do we figure out where the 50.5th person is? Count up. Good. By the first class, we've counted 13 people. Then we've counted 13 plus 19, 32 people. Then 62 people. Stop! We have passed the 50th person because we counted more than 60 people. So 50th person is hiding in here. All right, Hafi, this is how you do it, right? We need to find, imagine, I mean, if you have 5 people, the middle one is the third one. Yeah, 5 plus 1 is 6, divided by 2 is 3. How do you find the third person? Well, look, if you've counted 2 people already, and then in the next class you count another 2 and you're up to 4, well, you've passed the third person. You find the median one. That's the idea here. James, this is maths. Same for every exam board. So in the first class, we counted the first 13 people. Right, imagine this frequency literally means 13 people. And then we count another 19 people, which means we've counted 32 people in total. And then we count another 30 people, so we've counted 62 people in total. That means at some point we counted the 50.5th person. James, yes, half. So the class with the median is the same, is 20A 35. Number 3, estimate the mean age of the visitors. How do we do that? We're going to use the midpoint of each group. So midpoint, add them together, divide by 2, 0 plus 10, 10, divide by 2, 5. 10 plus 20, 30, divided by 2, 15. It is Tamina. That means we must have skipped the 50th person getting to that point. It's definitely not going to be after. It's going to be before. And it's definitely going to be after the 32nd person. 20 plus 35, 55. Divided by 2, 27.5. 35 plus 50, 85. Divided by 2, 42.5. 50 plus 70, 120. Midpoint 60. Midpoint 80. Very good. So then we do frequency times midpoint. So 13 times 5. 65. 19 times 15. 285. 30 times 27.5. Almost done, Maynard. Hang in there. 825. Thank you, Javeria. 23 times 42.5. 977.5. 60 times 11, 660. 4 times 80, 320. We'll find out very, very shortly, Aisha. Then we add them all up and divide by 100. So let's see, we've got 65 plus 285 plus 825 plus 977.5 plus 660 plus 320 and divide that by 100. 31.3, absolutely correct. So it's going to be 65 plus 285 plus all of that stuff over the number of people, 131.3. Very, very good. Correct, Juveria. All right, kids. That's it from me. You've hung in there. You've done a great job. Paper 3 out of 3. Some of you have been here since September. If there's anything you'd like to ask me, I'll stay for another couple of minutes. Otherwise, all the best of luck tomorrow. You got this. And look forward to a nice summer. It's the dream, Ali. Nah, try for yourself, Maynard. No worries, Valley. Thank you, Ria, as well. Question 19, Josiah. All right, not a problem. Bye, Banipri. All the best of luck. Don't worry, Brownie Rose. Question 19, yeah? All right. What's your question? Aisha, yeah, I'll go question 30. Yeah. Just, Izzy, I would recommend actually making sure you get a good night's sleep. Oh, thank you, Tamina. It's very kind. All right, fine. That's amazing news, Dee. Very good, very good. All the best of luck. All right, I'll do this and then I'll do question 30. Okay? Don't worry, Josiah. Let me go through it. Okay? So first of all, the mean number of points scored per game. Now the mean, uh, is just you add them up and divide by the number of numbers. So 0 plus 0 plus 0 plus 0. Bye, Tamina. Bye, Sapphire. What sleep? Add them all up and divide by 16. Yeah, correct, Alara. You'll be fine. All right, median number of points. Now, median means we just want to find the middle one. So we start crossing out from the outside. But because we have an even number here, there's not going to be just 1 in the middle. There's going to be 2 in the middle, right? Here's our middle values, 1 and 2. So the way we do the median is, this case, we just add them together and divide by 2. So we go 1 plus 2 divided by 2, which is 3 divided by 2, which is 1.5. Then the range is just the biggest, which is 5, minus the smallest, which is 0, so it's 5. And then finally, guys, no sharing of personal details in the chat. Finally, we're just comparing the medians and comparing the ranges. So if you've got your median, essentially tells you something like how many goals you score on average. So the Brookdale Bears score more goals on average. They tend to score more goals, so they have a higher median. But they have a smaller range, so they tend to score the same number of goals, right? There's no big differences because the difference between the biggest number of goals they score and the smallest number of goals they score is only 3. The Green Hill Giants have a range of 5. Right, Shakina, I see you. Question 12. Bye, Safi. Right, I'm going to go to question 30, which we didn't do. Let's see. Yeah, Maina? Question 12, question 8. Please keep reminding me when I finish this. Mike has recently, guy with no face, yeah, I think so. Mike has recently moved to Canada where milk costs 162 Canadian dollars per litre. He used to live in the USA where milk costs 3.12 US dollars per gallon. $1 US is 1.397 Canadian dollar and 1 litre is 0.212 gallons. How many more Canadian dollars will it cost to buy 10 litres of milk in Canada than in the USA? So let's see. In Canada, 10 litres will be $1.62 per litre times 10, so it will be 16 Canadian dollars. While in the USA, $3.12 per gallon. Well, first of all, 1 litre is 0. So to go from litre to gallons, we multiply by 0.212. To go from gallons to litre, we divide by 0.212. So 10 litres is equal to 10 times 0.212 gallons, which means it's 2.12 gallons, which cost 2.12 gallons times 3.12 US dollars per gallon. So that cost in US dollars is going to be 2.12 times 3.12, 66144. US dollars. And now we want to go from US dollars to Canadian, so we multiply that by 1.397. So we go answer times 1.397, 9.24. Canadian dollars, 9.24. So the difference is Canadian dollars, 6.96. Nice. Correct, Aisha. You are absolutely correct. Well done. Right, question 8 and 12 people were asking about. Let's see. Okay, Hal, yeah, I'll talk about debit, credit, and balance. Don't worry. So question 12. Did someone want me to go through this again? Speak now or forever hold your peace. Moiz, it's just to warm up, innit? All right. All right, so quickly. Here's the way to do this, right? We're saying, here's another way of thinking about it. Oh, hang on, there's a quicker way of doing this, isn't there? I want to, no, raise all ink on slide. There we go. So 20 minutes. There are some number of minutes that you should know as fractions of an hour. That's a third of an hour because 20 divided by 60 simplifies down to a third. 45 minutes. 45 divided by 60 simplifies down to 3/4 of an hour. So here's what we do now. Javier cycles for 20 minutes, a third of an hour, at 6 kilometers per hour. Now, speed equals distance divided by time. Judy, sure. Which means that distance is speed times time. So, for the first part, 20 minutes, 6 kilometers per hour. For part A, we're going to have 6 kilometers per hour times a third of an hour, which is going to be 2 kilometers, right? If you do 6 kilometers in 60 minutes, then in 20 minutes, you're going to do 2 kilometers. That's what we're saying. For part B, our speed is 10 kilometers per hour. Our number of hours is 3/4, and 3/4 of 10 is 7.5 kilometers. So total distance is 2 plus 7.5, 9.5 kilometers. Total time, 20 minutes plus 45 minutes is 65 minutes, which is the same as 65 over 60 hours. And then what you want to do is just distance. Average speed is going to be distance divided by time. And if you do that, you're going to get 8.77 kilometers per hour. All right. Someone was asking, oh no, I'm going to do the credit and debit first. Okay, so let me put in a new page. Oh yeah, I guess I should say, leave me a review if you found this helpful. all of that. Yada, yada, yada. Right. Okay. Guys, if you're not here following the maths, go get some rest. You've got exams in the morning. Hal, are you there? All right, greetings. So, what is the definition of credit? What's the definition of debit? And what's the definition of balance? Right, credit is money in, debit is money out, and balance is the total amount left in account. Thank you, Mina, too kind. So, for example, bank balance is, I don't know, I don't know, £685. Income is £1,280 this month. Bills. Thank you, Maynard. Oh, if you've already done one, no need, Alara. Food shop is £127. What is the balance at the end of the month? Right. Right, you just need to identify what's coming in. So this is credit, which means it gets added. And then these are debits, which means they get subtracted. And so your new balance is just going to be whatever that is, right? So you take your old balance and then you add on any credits and subtract any debits. 1497. All right. Thank you, James. Thank you, Hel. Guys, I'm tempted to leave it there. We've gone half an hour over and I'm pretty knackered, to tell you the truth. So, if you have questions, trig question, Maynard, there's lots of trig in my last cram. Go back to cram 2 towards the end of that. Thank you, Juveria. And great effort this year, seriously. Maynard, I promise. Cram 2, you can find the video. Just search my name. You'll find cram session 2. There's lots of trig towards the end of that one. So you can just watch me explain it there. All right. Good night, guys. All the best of luck. You got this. Thank you once again, mods. Yeah. Bye, Fatima. Thank you. All right. I'm out of here. Bye, Donald. And have a great summer. Yeah. Remember, GCSEs are not the end. They're just the beginning. Thank you, Aisha. Bye.